Now, before going on and figuring out what the mass of this thing is, given a density function in terms of r theta and z, a row of r theta z function, let's make sure we understand this approach to the limit. Our z's are what we're summing up between k equals 1 and p sub I. That's our perturbation of z, so that the delta zk's become dz's, and our limits on the integral are from 0 to the square root of a squared minus r squared. Okay. Then for that we integrate with respect to theta, which is pretty straightforward. There's no theta dependence. Theta goes from 0 to 2 pi, so our integral with respect to theta becomes integral from 0 to 2 pi with respect to theta. And then, and when I wrote this down in class, I didn't have my r in here. I was being careless. Then we have our last summation where the ri's change, they differ, and we then sum those from 0 to r equals a. We get the integral from 0 to a with respect to r. And it's the integral of r dr because we have an ri delta r sub I. Okay. Now the question becomes, what is the mass if we're given a density function? Now I probably should have used a delta instead of a rho because in a minute we're going to do spherical coordinates and that might get confusing. So maybe I'm going to make that change now. I'm going to change the rho to a small Greek delta. Okay, so we want to think about what the mass would be. Now, we want to go through the same process, and the crux of it is, all we have to do is figure out what the mass of this one sample region is. One little rectangular solid here. What's the mass of that region? Well, fairly simple. We multiply the volume of the region, and we've got the expression for the volume, by the density. And people said this, people understood that this is what was going to happen. The density evaluated at our sample point. So what we get, and I hope I've got the right board behind this one, yeah, I guess we do. What we get is the approximate mass of the ijk volume increment is density function, and now I'm using the del. Now let me change all of those just to avoid an inconsistency in the notation. Okay? Delta evaluated at the sample point of the typical region times the volume of the region. That's not written out really well, but it reads Ri star, delta Ri, delta theta j, delta zk, and there is a closed parenthesis there. But it ran afoul of the edge of the board. Okay. Well, that means the total volume is just what we get when we sum this, times this, and so forth. And that sum approaches the integral that you get. And the integral is just the same as it was before, except that you have a delta of r theta z. So that would be the integral. Okay, well next we want to look at how we do this in spherical coordinates. And we're going to take we're going to do this a little more quickly, and then we're going to verify that if we do the volume integral in spherical coordinates, we get the volume of the formula for the volume of a sphere.